Hey everybody, Mr. Fortin back here with a final video for this lesson. So anyways, I just want to wrap up here by showing you guys a couple of great questions that came streaming in after Friday's lesson. So before we talked about this whole tangent thing, right? Like we looked at slope angles and slope ratios, and you obviously just had some questions. Where is this leading? And anticipating how will I be able to look this up? How will I be able to do it? So anyways, on Friday here, I got a great question from somebody right here where in Friday's assignment, it had you look at an 11-degree angle, and then you figure it out on a grid, right? Like that it was rising 5 and running 25. So then naturally the question here, this is somebody really thinking ahead to like when we just go back away from the grid, away from graphs and back to geometry of 11-degree angles, maybe 11-degree angles in a right triangle. How am I going to be able to know these ratios, right? Like besides looking at a graph, right? Looking at a grid where I'm rising 5 and running 25. So that's how I can get the ratio. How am I going to get these ratios in the future? Okay, so this is a person who realized on Friday that one of the points of this assignment was that every individual angle, every reference angle is going to have a unique opposite over adjacent ratio. And what you should have learned today in class is that that opposite over adjacent ratio is called the tangent, okay, the tangent here. So if you didn't get it after this class, like the lesson today, hopefully you're going to get it after here in a second, is that yes, what I sent this person in a video on Friday was you can use a calculator for this. To get an 11-degree angle here, to figure it out rather than just like counting it out, right? Because that's like kind of lame counting it out here. To get an 11-degree angle, to get the opposite over adjacent ratio for that, okay, you have to do what? Right, to get the opposite adjacent ratio. You have to use the tangent function, okay? Because tangent of 11 degrees is going to be whatever this opposite side is over the adjacent side. Tangent, TOA. Tangent involves the opposite over adjacent. TOA, T-O-A. Anyways, that'll make more sense once we study the other functions here. So tangent 11 degrees, right? Instead of just counting up, right? I think what you did on Friday's lesson was that, well, this one's rising 1, 2, 3, 4, 5, and running 25 here. Hey, we got computers that do it for us here. We also have resources like page 271 that can help us look this up for us here. So for an 11-degree angle, I got it, 0.194. So it isn't exactly 5 over 25. It's approximately 5 over 25 for this one, right, which you counted on for on the grid. But really, it's exactly, right, tangent 11 degrees is exactly 0.194, right? So tangent 11 degrees is 0.1944, a lot closer to that here. So anyways, so to answer that person's question, how am I going to do this feature? This is just a great question. I think it's a great question. How am I going to be able to do this in the future when I'm not going to be on grids? Well, we have all the answers already. Every acute angle has this unique opposite over adjacent ratio. So you simply need to look it up on page 271 and get it, 11 degrees, and find the tangent. Remember the tangent is this column here, 0.1944. And again, you could also use a calculator for that. So you can bop into your calculator. You can hit that tangent button, right? A lot of people struggle with finding that on there. That's why I do it again and again and again. Tangent of 11 degrees. Make sure you're in degree mode. You might have to Google how to set up your calculator in degree mode because I can't show it on everybody's calculator here. Hit enter, and there it is, 0.194. So you know that the ratio is approximately 5 over 25, right? If I do 5 over 25 on a calculator, I should get 0.2. So it turns out that it just appeared when you guys counted it on Friday, it appeared like it was a 5 over 25 ratio. It's pretty close to that. It's pretty close to 0.2. It's 0.194. So really good question. Use a calculator. You can see it more clearly. You can just use it on your computer too. You can Google tangent of 11 degrees, and I guarantee you it'll give you an answer. You might have to change degree mode. Actually, I can do that in a video that I sent out earlier here. But tangent of that's about 0.194 if I'm on degree, not radian mode, right? I want to be in degree. So you see this degree here. Hit the button. Make sure you're in degree mode, and you'll get the answer. All right, that was one really good question. Here's a second question. This is probably even better here for your purposes in kind of making sure you know how to do this now. But hopefully coming out of today's lesson, you know how to do this too. Great question from another person here in third block. Hey, I got my great questions third block, fifth block, seventh block. Pick up the pace here. Ask me some good questions. I'm willing to answer them here. So this person here asked me, well, how do I find the angle if you have both the sides, right? How do I find the angle if you have both the sides? So maybe we'll look at an example from the textbook where I actually have to do this, because you're going to have to do this in the problem sets. How do I get the angle if I have both the sides? Well, maybe let's look at here, but you should have gotten it from the lesson and today. What you want to do, if you find the angle from both the sides, you want to use a function called the inverse tangent function. Inverse tangent. And that you're looking for tangent to the -1 power on your calculator, okay? So this person's kind of asking, well, how do I go backwards? I know if I have an 11-degree angle, that's going to be in a 5 to 25 ratio, because that is roughly what the unique ratio is, opposite over adjacent. That's the tangent for 11 degrees here. What if I just happen to know the ratio, right? How do I get the angle? How do I go backwards? How do I take that unique ratio that applies to one angle to then tell me what the angle is? You can certainly do that. We have that stored. Human beings know what the answers are here. It's stored in a calculator. It's stored on the table on page 271. Okay, so how do I find the angle if I have both the sides? Let's look at that problem here that I was planning on showing to you, this exact thing. You'll have to do this potentially on the homework here. It says, find y degrees to the nearest degree. Well, here, okay, I have y degrees. When you do problems like this, definitely label up what side is what. Here, this is the right angle. This is the hypotenuse. We're not going to worry about that one yet because we're just doing the tangent ratio right now. And the tangent ratio is, got my opposite, and I'm going to set that over my adjacent here. So here, when you do a problem like this, you want to do the tangent of y degrees. We know there's this particular angle measurement where its opposite over adjacent ratio is unique to that angle measurement here. And here we have the ratio 8/15. So there's some angle right here in an 8, 15, 17 right triangle, right, where opposite the 8 angle, we're going to know that angle measurement. That's going to be true for any 8, 15, 17, or anything in that ratio, right, the side ratio here. So 8 to 15 is going to be the tangent of a particular angle, right, We don't know what that angle is yet. So the way to do this here, right, if I've seen this in textbooks, they'll do the workout here, is what you want to do is that tangent to the -1 button. Okay, you want to do inverse tangent here because you don't know what the angle is. You don't want to take the tangent of the angle. You don't know what the angle is. You need to find what the angle is here. So what you want to do is you want to do tangent to the -1 power. It's called the inverse tangent. Basically, when you see -1 in math, a lot of the times as an exponent, that's going to say do the opposite. It means do the opposite, undo something, right? Undo something. Anyways, it's just a notation thing. It's not actually, you're actually taking something to -1 power. So anyways, tangent to -1, that stands for something called the inverse tangent, okay, inverse tangent when you do the tangent -1 button, and you're going to do that for the 8/15 ratio that you know exists, and then it's going to tell you what the angle is, right? It's going to tell you what y degrees equals, okay? So we take the inverse tangent of that ratio, it tells us the angle, okay? If we had an angle, we took the tangent, it would tell us the ratio. Inverse tangent of the ratio tells us the angle. Anyways, hopefully you get the idea here. So again, you have to make sure in degree mode. I'm going to hit second, okay, because again, I don't want tangent. I want tangent to the -1 power. So I'm going to hit tangent to the -1 power, and then I'm going to do 8 divided by 15. And it's going to tell me my answer there is going to be 28 degrees, right? 28 degrees, okay? So the 8/15 ratio is unique to the 28.07 angle, right? 28.07 angle. So here is how I can get my answer. And it says find it correct to the nearest degree. So I'm just going to do 28 degrees here. Okay, y degrees is 28 degrees. Okay, so here, this is approximately 28 degrees. And that's your answer to number 8 on that problem set. So you could have gotten that degree measurement from your calculator. Again, you could get it from what page? I'm using this page a lot, page 271. Okay, so 8/15, if you did 8/15 on your calculator, you get 0.53 or so. So you could have found that in your trig table, right? Using your trig table, look for the tangent where it's approximately 0.5. You know, oh, I got 0.53 here. That's pretty close. That's the closest. That's gonna be the closest one. And look, it's 28 degrees, right? So you got it stored for you in the textbook. What all these tangent ratios, what they apply to, what reference angle they apply to, and vice versa, right? With all the reference angles, what's their tangent ratio? You can use them to go both ways. Also, have it in a calculator. You got to be in degree mode. Okay, so great questions there from Friday. I wanted to acknowledge that, but you should have answers to those 2 questions here. How do you find the angle if you have both sides? Inverse tangent, okay? Tangent to the -1 power on your text and in your calculator, and then put the ratio next to that. Or you can just use page 271, okay? How do I get the unique ratio, right? The tangent ratio, if I know the 11-degree angle, how do I get that without counting it out, right? It's pretty manual that we did on Friday. We'll use page 271. Look up the tangent ratio value that's stored in the trig table on page 271 for an 11-degree angle, or you just hit the tangent button, not tangent to -1, just tangent button, 11, tells you, right? It's approximately 0.1944. Thank you guys for your great effort Wednesday, Friday. Thank you for these questions. And now I think my lesson here is done. went on for a while. Tangent, trigonometry. Had to get into it here sooner rather than later. All right. Have a good Monday and Tuesday. Bye.